You should have heard the words I used this evening when I dropped my stuffed bell pepper on the floor.
Oh, no.
Tragedy of tragedies.
It was a tragedy. I mean, some days life gives you stuffed bell peppers, and some days you give them to the floor.
Gosh.
Nah, it's terrible.
It's terrible.
It's terrible. And Marshall looked at me, my husband, he looked at me. He said, Kiki.
Do you mean to do that?
You wonder where Kai learns those words.
Oh, that's the worst.
I try and be I am so professional on this show, everyone. We're here. Justin's here. We have audio that works for Justin. He is on his way to the moon currently.
Yeah.
He is
Spaceships of today are made out of brick. It just turns out it's what works in space. It's
for the shielding of the radiation.
Perfect radiation shielding. Yeah.
It's particle radiation shielding. It's better than
brick and mortar.
Better than what they've got right now, which apparently gets little holes in it.
Oh, that's a whole conspiracy thing now, too. Have you been hearing this conversation?
Now it's making me laugh.
Oh, my gosh.
I just thought it was just generally funny. So anyway.
Yeah, if you're not on the space station that's got a leak
that they fixed with tape.
And wait, what was it? No, it was worse than tape, though. It was like the first report I heard, like they patched with old rags. Like, how do you have an old rag on the space station? Shouldn't you be bringing new rags up to the? I don't know.
Wait,
did not sound like a fun situation to be in.
Did not sound like a fun situation, and we're glad everybody is safe. Very glad everybody is safe. And it's time to start our show.
Mm-hmm.
We're here. Everybody in the chat room, do our audio levels sound great? Are things going well so that we have the okay for launch from the chat room? We're live, clear, 5x5, ready? Yes, Fada. Thank you. We got it. All right. We are starting this show as soon as I can get my run sheet in front of my face to see the words that I'm supposed to say. Starting in 3, 2. This is TWIS. This Week in Science, episode number 686, recorded on Wednesday, September 5th, 2018. Getting medieval on your DNA. Hey everyone, I'm Dr. Kiki, and tonight we will fill your heads with Hawkeyes, sex differences, and a space elevator. But first,
disclaimer. The distant future is a long way off. At least it used to be. It used to be a lot further and much farther, as some may have said. When people refer to the distant future these days, though, they often mean what people used to mean when they said something was right around the corner. From the beginning of space to the outer edges of time, the pace of things on planet Earth is constantly picking up. So every once in a while, it's worth slowing down, catching up on all the wonderful things that go on in the world of This Week in Science. Coming up next.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And the good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back yet again following an American holiday weekend that did not stop science. Science keeps going. The news kept coming. There are many stories, and we have brought them. And we are very glad also to be joined once again by Justin. Your move went well. You have internet and audios?
I have both of those at the moment. Seconds ago, I did not apparently have both. But yeah, things worked out.
All right. So we will see what we can do to make it through the show. Hopefully, all will run smoothly. We do sometimes work on the whims of technology, but we'll keep going because that's what we do. On this week's show, I brought some stories about algae and hope, chicken and eggs, and sexy brain cells. What did you bring, Justin?
I've got middle-aged Germans,
What?
old cheese. Those are two different stories. And space elevator.
We haven't talked about space elevator for a really long time, so
For a really good reason. But now, this month,
we're gonna
the
move
first
along.
one is going into being deployed.
We'll talk about it. We're going to talk about this. What?
Yeah.
That's some serious news. All right.
Surprise announcement. Yeah, there you go.
Yes, surprise, surprise. Blair, what is in the animal corner?
Oh, the aforementioned Hawkeyes. Some invertebrate sex, been quite a while for that one. And self-aware fish.
They don't just swim around in their goldfish bowl.
No, they know who they are. They know who you are. They're judging you. We're going to talk about it.
Man, now I have to talk about this with my child. This self-aware fish.
Yeah.
Oh my.
I knew fish. I knew that fish were aware at least of me, but I didn't know that they were so much self-aware.
We'll see. Are they or aren't they? News at 11.
Ooh, or hopefully before that, because
Before,
that
yeah,
would be a
that's
really
gonna be-
long show.
11 like Central Time, maybe. I don't know.
All right, everybody. As we get into our show, I would love to remind you all that if you have not yet subscribed to This Week in Science as a podcast or on YouTube, you can do that. You can find us all good places that podcasts are found. As well, if you just visit TWIS.org, you can find information on how to subscribe if that's what you're interested in. But now it is time for the science. So let's dig into some chicken and eggs. You guys like that? You guys hungry for the science?
Mm-hmm.
And here I am talking about chicken and eggs, which came first, when really I'm just hearkening back to our conversation that you missed last week, unfortunately, Justin, about quantum weirdness and the double slit experiment. So we had author Anil Anandaswamy on the show to talk about this double slit experiment in which when light is looked at as a wave, it appears to have the properties of a wave and wave-like motion through those slits. And where the light ends up on the other side of those slits is based on physical properties of waves that we know fairly well. However, there are other moments in which the light slit, the light particles act like particles, and they go shooting through like little bullets through the slits and line up very differently than they do when they act like waves. Now, it's this observation, looking at things, that changes how they come out. It's the law of probability. The quantum world is ruled by probability fields. All the probabilities of the places that any little teeny tiny particle could be in any place at any time, right? So researchers from the University of Queensland, Australia, were, and also from the Neel Institute, have been looking at this question of quantum weirdness and whether or not things that happen at the quantum scale during weird events, whether they have to have a set order. And really, the weirdness means they don't have to have a set order. So they wanted to experiment with that and try and find out about cause and effect, or the idea of a chicken and an egg. And in their experiment, instead of having the light particles go through slits in a wall, they had them bounce off of mirrors of sorts. There were devices within their experiment that changed the polarity of the light. So light spins one way as it's traveling, and that's its polarity. and you can shift that to give it an opposite polarity. And in the experiment, they were trying to determine the whether or not the polarization could show the order of transformation. So, hey, at spot A, it switches the polarization in this way. At spot B, it switches the polarization in this different way. And can we actually see that at the quantum level? And so what they say, this is the researcher trying to explain what he did. Dr. Jackie Romero from this ARC Center of Excellence for Engineered Quantum Systems at the University of Queensland said, so that events can happen without a set order. You could take the example of your daily trip to work where you travel partly by bus and partly by train. And normally you would take first the bus and then the train. But in our experiment, both of these things can happen first. And it's called indefinite causal order. And at a macro scale in our everyday life, we can't observe it. It's not something we can observe. And so in their experiment, by measuring the polarization of the photons at the output of the quantum switch, they were able to show the order of transformations on the shape of light was not set. And so what this is, in addition to kind of taking the double slit experiment a step further, you're not just like, where is the light going, but how are we affecting it? They say that this is a proof of principle that they can use on a larger scale that can have practical applications like making computers more efficient or be used in optical communications, quantum computing, optical communications, these various things. It's weird. It's interesting. But although we know the egg came first in biology, the chicken and the egg come first when it's quantumly weird.
So it's the thing that I can most understand from last week and this week. My brain is still not fully there.
No,
but
it's not ever going to be.
It's I feel like I'm even behind where I'm supposed to be on this, but honestly, it just sounds like you find what you're looking for, and that's it. It's a self-fulfilling prophecy, kind of, because it's what you're measuring.
Right, it is what you're measuring, but in what they were putting together, there was this. So basically, the order could be one transformation A and transformation B, or you could have transformation B then transformation A. But because of the way quantum effects occur on particles, it's a superposition where both of those transformations are happening on the particle of light at the same time until you observe it.
Too much.
And
It can't be two things. How is it transforming from one thing to another and from another to one at the exact same time?
Because it's in the quantum world and it's
here. I don't like the science. This is why I loved math as a child. Because it was just very much, what is 2 plus 2? It's 4, done, end of story. Can you argue it's 5? No. That's it. I loved my very simple math that was just right and wrong. And that was it.
Yeah. So this is taking math.
Yes.
And putting it into an experimental setting. You know, what they have done with this experiment is verified an aspect of the mathematical theory. But when they're working with their mathematical theory, this is all intervals and probabilities and matrices, and the math is a bit different than the straightforward stuff we're used to.
So I got it. Quantum physics ruined math for me. Great. Excellent.
No.
I have to admit that as you started to tell that story, I realized that I had a laser optics kit.
I was wondering what are you putting up there? You're holding up your laser optical set just cuz.
One of the weirdest things about moving is you find all this stuff you didn't know you had. And it happened to be sitting right there as you started. So I missed the story because I was playing with my lasers. but I think something that Blair said does sort of, I think, ring a little bit true. And the study of optics is it does depend on what you're measuring and how you're measuring it.
Well, that's what our guest was talking about last week, was that the act of measuring something affects what it is.
No, it doesn't. I mean, I wasn't
it's
here.
Verified. It doesn't affect what it is. It verifies what it is.
I know it is. But here's the thing. It's a good thing I wasn't here last week because we'd still be arguing. But the weird thing about life is what I think it does, and this is that you're verifying, you're picking a perspective. Because one of the weirdest experiments within light is that light can be found to be traveling, like you said, Kiki, everywhere at once. So any sort of parameter of an experiment that you create is taking a perspective of time and space slice of that to see, to view, to be an observer, to create an observation point in a thing that's going everywhere and is totally unaffected by time. So I think you're both right.
And I
just go back to playing with my laser. Hang on, let me get the laser out again.
Go back to playing with your laser. I have some more fun stories for us right now. I just wanted to, I like chicken and egg stories. It's the age-old question, which came first. And now it's kind of like, well, if you're going to the quantum level, it all came first. Stop shining a laser at the audience.
Can you actually? I'm actually wondering if I held the laser at the
stop
long
it.
enough, would I start a fire in somebody's house if they were watching this on YouTube?
No, that's not going to happen. But you're just overloading the white balance on your camera, dude. All right. Next story up has to do with the female versus the male brain.
Oh, let me guess. They're exactly the same.
Absolutely not. No. And so this is an interesting one. We've talked before on the show about microglia, which are cells that are around the neurons. They interact with the neurons and can act as they act in part as the immune cells of the central nervous system, right? They get in there, they respond to things happening to help cells or shut them down if need be. And so some researchers from Max Delbruck Center for Molecular Medicine in the Helmholtz Association reported in Cell Reports this week of their study on microglia in female and male brains. And the senior authors of the study, I love the fact that they really got into this because they had been seeing so much research on male brains in animals in the lab, and researchers going, there's really no reason why we need to use both sexes. When there's a difference, right? So these researchers have been criticizing that male animals have been used more often. And so kind of really wanted to get into this. And Suzanne Wolf, who led the study, says at the University of Groningen, with whom we collaborate closely, there are plans to repeat our experiments with human brain materials taken from recently deceased donors. And she added that sex-specific differences can be seen in the frequency of neurological disorders. So the differences are there, but they're not sufficiently taken into account when treating patients. And so she's really hoping her study will help change this. And in the study, they looked at genes in the brains of male and female mice that are expressed only in the cells of microglia. And she says they identified more than 1,000 genes, 300 to 400 proteins that are regulated differently according to sex. Many of them are more active in male microglia, especially those that are involved in the production of self-defenses, those things that are defending the brain. And everything also suggests that the male cells, because of their genetic and proteinaceous profiles, act differently than female cells. And The researchers say the microglia of the male animals seem to be permanently at attention, ready to strike and keep order. And when they tested the voltage levels of the membrane, the male cells were at a higher idle voltage than the female cells. And when they stimulated the cells with ATP, they responded more than the female cells did. And so the response.
What does that mean? I mean, what is
ATP is the energy molecule. So when they stimulated it with the energy, there were higher ion currents, so that the signals these microglia are sending are stronger in the male cells, and there were increased production of certain proteins as well, which means that the male cells were basically ready to go. Male microglia cells, the immune cells in the brain, are ready to go at all times. And that may be good for protecting out of generally, but it could also be the cause of some of the male-dominated neural diseases that we see. And she explained also that the male microglia might actually be wearing themselves out faster because of the fact that they're constantly alert. And Dr. Wolf says in the female cells, proteins and genes responsible for protecting cells, such as DNA repair genes, are more active. In male cells, on the other hand, we see increased activity of genes involved in initiating programmed cell death. So that means that male microglia might be less protected against bad things that happen in the environment. So a bash to the head, or a stroke, some kind of injury. And so instead of responding in a let's fix it kind of way, just activate cellular suicide programs that lead to further neural problems. There's another study that was also recently published by some Italian researchers, and they were able to show that the cells of male mice had a harder time dealing with an experimentally induced stroke than the microglia of female mice. And then when female microglia cells, when they were taken from female mice and put into the brains of male mice, the effects of vascular obstruction, which occur during stroke, were less severe. So putting female microglia into the brains of male mice actually helped the recovery slightly. So, mice. How easily can we translate these results into humans? How easily can we take what we see in these sex differences in mice and translate them to what we see in actual diseases and disorders in humans? And that is the big question. But this is a huge area. We have not looked at the male and female brains in this kind of way before. And so this is awesome.
And that's probably the main moral is when we're looking at human brains, we need to look at male and female human brains differently. And that more than, the specific reactions, that's going to be harder to extrapolate. But that is, I think, the super important thing to go, okay, all our previous brain research, we now need to make sure that we are tagging as male and female brains and identifying trends and recognizing that this could be affecting a lot of things, medicines related to brains, therapies related to brains, expectations after brain damage. All these things could be extrapolated from data taken from just male, just female, lopsided data sets. Yeah, it's a really good question.
And then mostly Caucasian and Western world and different,
Yeah.
Yes. There's always going to be more and more nuanced approaches to these things. And then within any given survey, but if you just ignored the genetic makeup of the person and just said male or female, that's ridiculous, because there's all this genetic differences between individuals and the variation that could be somewhat at play. And then you got to look at their microbes, because the microbes affect the gene expression. So I mean, yes, it's very difficult. However, the broad brush with which science thought it was being very specific, which is now finding it's actually been painting with a very broad brush on these subjects, is still immensely helpful and immensely useful.
It is helpful, but when we're talking about things like How do males and females recover from head injury? And we have talked about on the show research that suggests that women are more susceptible to damage from head injuries during certain times of the month, where it seems like males are kind of evenly distributed across how head injuries affect their brains. We know that sports head injuries are a major thing we're talking about now. And if we're going to be talking about chronic traumatic brain injury, what is it about the genes and the proteins that are expressed in these specific cells in the brain? And yes, I know you always go back to the microbes. I love the microbes too, and there is a gut-brain connection. But what is happening with those immune cells in the brain, and what are their instructions to act in a particular way at a time? And what this is saying is there is a pretty dramatic difference in these immune cells in the brain. And our immune system is very important to keeping us healthy. And maybe this, when we're also talking about medications or things that cross the blood-brain barrier, how do we do that?
Yeah, and I mean, we've talked about the difference between male and female brains in other ways before. The fact that the female brain is done growing at, I think it's supposed to be around 25, and then the males don't finish until 28. That is a huge difference that we've been discussing for a very long time between male and female brains.
That's just because we're just catching up. So,
yeah. That's part of it, though. The
right.
mechanics are different, right? So if the mechanics are different,
development is different. Mechanics is different. Our brains are amazing and they help us do all sorts of things. And let's accept that there are some small differences that we should look at when it comes to medical treatments and understanding.
But what I would be really interested in seeing in the future is for them to drill down on that lymph material. Because the lymphatic system is so tightly correlated to our immune system. So this only 3-year-old, 4-year-old that we've even known that there's this lymph materials surrounding the brain that's in charge of taking out the trash. I'd be curious, like, forget the whole structure of the brain thing. Just see what differences there are there, and you may see in that structure alone why there might be a different immune system.
Yeah. So tying all these things together, I think, is absolutely important. I think, though, the microglia, they act within the brain probably over a couple of millimeters. They are very localized actors within the brain. And so what they are responding to is very instantaneous, localized needs of the neurons. And so you have the localized system that can have fast-acting responses, and then you have the more distributed system that deals with the whole communication of the system. And so I think there are different functions for all of these players that are very important in their own way and also well tied together. I mean, we're a big system. But yes. And speaking of systems, my last couple of quick stories here for the top of the hour. Gene editing. Oh my goodness, it's coming to fruition. A new report this week in Science looked at 4 dogs that have been treated with CRISPR gene editing to fix a mutation and allow them to create the dystrophin protein that is not produced when people have Duchenne's muscular dystrophy. So these dogs had a disease mimic of muscular dystrophy, and they were given this CRISPR treatment. In the past, we reported positively on results in mice that were given this CRISPR treatment for the muscular dystrophy similar disease. That was positive and successful. Here again, they gave the CRISPR intervention to these dogs, followed them for only like 2 months, and the protein started being produced in all the tissues that were being affected. Most importantly, the diaphragm and the heart. Muscular dystrophy is a disease that affects a small number of people, but over each year that are diagnosed. But overall, there are many people affected by it. There is absolutely no cure, and people die, and there's no cure. There's nothing. And this is the first study using this gene editing tool on a large-bodied animal. So it's only 4 dogs. It was kind of limited in scope, but this is a very positive step that suggests that maybe after the positive mouse study, now this small positive study, that more studies need to be done, and maybe it needs to be kicked up to human clinical trials. And then and yeah, it's super cool. And then speaking of human clinical trials, there was a study in humans, not using CRISPR, but with using something that's called a zinc finger nuclease. It's similar to, it was developed earlier than CRISPR. It's just a different gene editing tool. It goes into the gene and snips them up a different way. This was tested on 4 human people who have something called Hunter syndrome. Human people.
Human people.
Yeah, there we go.
Instead of these mouse people that they keep doing all these.
No, human people. This is a biotech company called Sangamo Therapeutics out of Richmond, California, and they reported data with they have a total of 4 patients that I guess have been given this zinc finger nuclease treatment for their Hunter syndrome. And in Hunter syndrome, there's a protein, an enzyme that their body does not produce. And because the enzyme isn't being produced, there are sugars that build up in tissues. And when the sugars build up, it damages the organs and heart and lungs and can lead to early death. And this is a new treatment for it and very positive results. They have 2 patients who had their sugar levels drop substantially and their enzyme. But it's interesting that their enzyme levels were not going up, but their sugar levels were dropping. So it's an interesting question. And someone else who looked at the results says it's hard to know what's really going on. But there's definitely, this is again, gene editing, potentially a very positive step for another disease that is already, it's in human clinical trials, and we'll see what happens. So odd and interesting that to think that we're snipping away at the genes of, that disease.
Yep. It's like the disclaimer. It's this far off kind of science fiction-y future that we've been talking about for so long is just getting so close.
Yeah.
And mostly it's very exciting.
Yes.
Mostly.
Yeah.
You know what I'm excited about?
What?
Hearing a story from Justin.
Justin, we missed you.
Yeah.
Okay. Yeah. I'm gonna go with the space elevator first. Yeah. This is happening, and within a week or two, it's coming up soon. This is a team of researchers out of Japan have been working on this space elevator, and will conduct the initial test run this month. They're going to, they say they could use a carbon nanotube technology in this, which is more than 20 times stronger than steel, to build a lift shaft that is going to sit some 60,000 miles above the Earth, with the cable that would presumably be able to reach the Earth's surface in order to lift objects up and out into the orbit. That's a mighty long cable. For the current test, a miniature elevator stand-in, a box just about 3 inches long, couple centimeters wide to mix measurements, is gonna get launched up in an H-2B rocket sent up by Japan Space Agency, JAXA. If all goes well, it's gonna move along a 10-meter cable suspended in space between 2 small satellites that will attempt to keep the cable taut, and the little elevator will move from one satellite to the other,
and then someone will tightrope walk along it.
right? I know they're gonna have cameras. They're gonna have cameras filming the elevator's attempt from the satellites. So now that you said that, I'm hearing na, 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 na,
Yeah.
na, 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 right? Little circus tightrope music, please. Yeah, and so this is if this works, I guess this is the first time anybody's tried to move a space elevator in space.
Mhm.
I assume it will work, right?
I thought a space elevator was supposed to be tethered to the Earth's surface.
Yeah.
This is an elevator in space. What? I don't understand. What's the confusion? Isn't that what we're going for? It's a little elevator that's going to move between two satellites.
No. I guess there are, if you're going to think of it that way, I guess there are a couple of different designs. There are cables that can allow movement between satellites that are then those satellites are tethered together. But the space elevator that we've been thinking about for ages is that you have a bit that starts out in space and you build it downward and use the Earth's gravity, and it tethers down to a place on the ground. Then you use the cable to move things up into space so that you don't have to use rockets.
Just a crazy idea.
Yeah.
But of course, that is what they're going for. And they're talking about, which I guess, I mean, you get weightlessness, you get into space, you get your space wings from NASA if you go 50 miles up. They're talking about putting the anchor to this thing, to a space elevator, as you described, 60,000 miles out.
Good. Keep it far away from Earth.
And running the
You think it's
cable
gonna crash
all the way
down?
back. No, and running a cable all the way down to Earth with nanotubes. So the idea is that anchor out in space means stuff isn't going to fall down. You have something far enough away, in orbit enough, way out there, so that even if you pull on it, it's not like, not like a balloon that you can just rein the thing in. It's got a lot of holding power just sitting out there in space. And then they'll be able to, but they're first testing the elevator mechanisms themselves in 0 Gs in this test to make sure everything will work when they build the 60,000. They're working at, it takes a long time to make a 60,000 mile long cable, Kiki. I mean, this kind of thing cannot be built overnight.
And they say so they want to use carbon nanotubes, which is the material that all space elevator hopes have been tied to. Yet we still can't produce carbon nanotubes in the size, quantity, or way to create an appropriate elevator cable ribbon for this task. And everybody still says, nope, it's going to be carbon nanotubes. They're going to do it. And I'm sure it will happen eventually. Like all the things that it's not immediate. It's science and engineering, stepwardly moving forward.
Yeah, it'll happen eventually, just like the flying car, right?
No.
Yeah, it happened. It just wasn't. Yeah.
It's just a bad idea.
Yep.
Well,
So the thing though is like, this is the distant future. Like how long you say we've been talking, people have been talking about this forever. Well, I guess the first time somebody
like 10 years. No, it's been longer than that.
It's been 122 years, 23 years.
Right.
The first time it was mentioned, somebody looked at the Eiffel Tower and said, hey, why don't we do that, but go higher and eventually we'll be in space. That was like this is before, anybody got to orbit. That was like, we could just keep building the Eiffel Tower higher and higher till eventually we would be in space. Now, that idea obviously didn't come to fruition. But the distant future of, since then, because it's like one of those technology gaps. Instead of building a ladder to space, we're like, oh, no, we'll just put some fuel under this, launch it up there. We got all this new technology, satellites, all this other stuff going on. And still just building a ladder to space hasn't happened.
Yeah. And what they're doing here, I mean, this is just a proof of concept. This is just to show that they can start getting it going. Can they get the mechanisms? Can they actually build a little cable-y thing in space? Can we start creating this thing in little tiny bits? Can we just start the project? Is this something that can work? Proof of concepts are always very important. I don't know. I just still forever, I read the Mars trilogy, and it was in the Mars trilogy where there was a big war and someone bombed the space elevator. Not a nice ending there for that little path.
If I was wondering why somebody would even pursue it, because if somebody could come up with a space elevator, it would be the golden ticket to having all of the money on planet Earth. Like,
there's that, right? You would control easy access to space because it would take care of the weight, the weight issue with getting into things into space, the fuel issue for getting things into space. There, a space elevator would be amazing.
Everything costs its weight in gold to put it into space.
Yep.
It's actually gold might be cheaper to put into space than no, but it's just like that's the thing. It is insanely expensive still. So yeah, if you could put something even into a pretty decently low orbit, you would have people lined up willing to pay you immense amounts of money for little comparative energy output. Well, you got to get it up there in the first place. That's the hard part. Once, then it's just a ka-ching, ka-ching.
I think it's interesting, though. They're similarly to the whole new space movement, which is going through an amazing golden age. The word gold keeps coming up right now. It's going through an amazing growth period. There are commercial companies that are getting us closer and closer to space and to more civilian space travel. There are companies working on ideas for mining in space. There are companies working on so many things, and space is becoming democratized in a way because there have been people working behind the scenes, working on the ideas that everyone believes in. And at one point, decades back, people looked at them and said, "You're crazy. We're not going to go do that. We can't go do that. No, you're crazy." And they were on the fringe, but that didn't stop them and they kept going. And I'm wondering if the space elevator is going to, it's not going to be decades. This is going to be something still like 100 years off, I think. But I'm just wondering if the space elevator is going to go through that as well, because there are people who really believe this idea is going to work. They're going to fight for it and push for it. And even though people say you're crazy, they're like, I want all that gold.
Well, and even if you demonetize it and don't turn it into the purely capitalist effort, it is the first step to realistically being able to build things in space. And so when we talk about these ideas of colonizing Mars or the moon or any of this sort of thing, one of the big obstacles is putting all of the material there that we would need to get there. If you could raise it up into space, build it there, or actually, I guess you could build it here if you got the space elevator. It doesn't really make a difference. You just raise it up and assemble it. You wouldn't even need to assemble it in space. Build the whole thing down here, lift it up. But you can build bigger once you're in space, right? Then you can start talking about getting those things to the moon and space that you would need as the initial infrastructure building blocks to do a settlement kind of a thing.
Yeah. I'm just wondering, though. I mean, the arguments against it, I have them too. Because it's like in your mind, you're like, how could this possibly work? Fada in the chat room is saying, all space elevator engineering theories neglect common constraints, like changing major weather patterns, earthquakes, earth plate theory, gravity, so many other things in nature that would rip any attempt at it. Yes, even with carbon nanotubes to shreds. And so the question, like, really, do you think engineers are not taking all of these things into account when they're thinking about something that could potentially be really dangerous to life on Earth, to people on Earth? Are the engineers are they not taking into account? I want to make sure they are, because it's not like a bridge that gets all wobbly and swayy.
Right.
Like, that thing better work first time.
Apparently, we underestimated the need to anchor. So if you live along this latitudinal or longitudinal line, you might want to move, because there's a big cable that's going to keep going around and around the Earth, destroying everything in its path.
Its path, exactly.
Oh, yikes. The space elevator is coming.
It would take a long time for it to fall. You might be able to get out of its path.
Oh my gosh, we could have like a futuristic Jack and the Beanstalk.
Yes.
Some future robot child of the future goes climbing up the space elevator.
Comes running down with those golden moon eggs.
Yeah.
Speaking of golden moon eggs,
Yeah.
I think it's time for Blair's Animal Corner.
Is that a real segue?
She loves our creature, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels. Then I'm
Blair.
It's been so long. I have some invertebrate sex to share with you today. It's all
Yay,
about,
share away.
it's all about cockroaches and about
Ew, maybe
cockroaches.
keep it to yourself.
Yeah.
Blair, we decided keep it to yourself this
Oh,
week. Yeah, we
man.
don't want to hear about it.
But
No.
cockroach sex is really interesting. Come on.
Okay, now I'm intrigued.
All right, then.
So, for starters, the way that cockroaches have sex is male cockroaches lure females into mating position by secreting a sugar-rich substance from a gland in their abdomen. The male exposes his sugar glands, he lifts his wing covers, and he turns his rear towards the female.
So he's a sugar daddy with a sugar belly?
Yes. Then the female crawls onto the mate's back, onto the male's back. This is an odd role reversal in the animal kingdom. And if she sits still for long enough, they can mate. She only has to sit long enough for the male's hooked penis to ensure that the female will not detach during their 90-minute copulation. During mating, the male transfers his sperm in a spermatophore, which also contains nutrients for the female and the eggs. It's a nice little consolation prize. Thank you for that 90 minutes. Here is some nutrients.
Now, is that a consolation? Isn't that a bonus? How is
after 90 minutes, I don't know, maybe she's looking for a little consolation. But anyway, there's lots actually still to be studied with the cockroaches and their mating habits. It mostly stems from looking at certain things that we anticipate with the way mating works for animals and whether you're a high frequency mater or a low frequency mater. And usually in a lot of species, we notice that if you copulate more, if you give birth more, if you have more offspring, it affects your longevity. And in this study, which I'll get to in a minute, they counted how many females gave birth to baby cockroaches and the total number of offspring. And they found that the males that had the most opportunities to mate, we'll get back to this in a minute, had around 200 offspring on average during their lifetime. Some individuals had more than 500, but the males that mated only once a month had about 50 offspring. What's really interesting is that despite that previous research, the male insects that were mostly sexually active did not live shorter lives. So this is very interesting. It wasn't what they anticipated. Now, this all brings us
really strong cardiovascular systems from all that.
Well, there's a
Yeah.
question here as to why this is happening. And this comes now to the main heart of this study, which is all about what the males eat. So in this study, it was a 16-week study. They gave males free choice between two types of feed. They contained different amounts of protein and carbohydrates, but were otherwise similar. They introduced receptive female cockroaches to the male cockroaches at varying times. One group of males were given one chance a week to mate. Another group had the opportunity once every 2 weeks. A third group had the opportunity once per month. And a fourth group never got an opportunity. Sorry, buddies. So what they found was that the cockroaches that mated most often favored higher protein food.
Okay.
So mating more protein, which might be for a bunch of reasons. The first and foremost one that comes to mind is that making sperm and making those nutrient packets in the spermatophores requires protein.
Mm-hmm.
So that would lead you to believe that this has something to do with that. And so this leads us back to the very first question that I asked, which is, why is mating constantly not affecting their longevity? The hypothesis of these researchers is that the reason we see decreased longevity with animals that are copulating more is because they don't have access to different foods. So when we do this in a lab scenario, or even in some wild scenarios, they can't adjust their intake based on their needs. And so they end up depleting certain nutrient stores, and it affects their ability to live as long as everyone else.
So in the lab, they're getting the same meal every time, just like the control group who's not having all the invertebrate sex.
Mm-hmm.
And so normally it'd be like, I need to go and eat 2 dinners tonight because it's been a really long day.
Yeah. Or keep your potatoes. I just need the steak. Yeah. 2 steaks, no potatoes. Thank you. Yeah. So this is an interesting question. We don't know the answer yet. We don't know how far reaching this is. There are lots of suggestions from the researchers here that this might extend to other groups of animals. But it does give us an opportunity to look at certain things, like in population dynamics, if the availability of certain nutrients affect that. Does it affect longevity? Does it affect how often animals are mating? Does it affect how successful those matings are? Because also it takes a lot of protein to build entire new humans, like the females need to do, or entire new cockroaches, if you're a cockroach. So there's a question here that for me was it was one of those light bulb, well, duh moments that haven't really been discussed in things like conservation too closely. That if, for example, if you're trying to help save a species out in the wild, you need to make sure that the nutrients available are such that they're set up for success for reproduction.
Mm-hmm.
And if there's an animal that isn't reproducing and you would like them to be, maybe the availability of nutrients is off.
Oh, pandas.
No, this is totally true about pandas, right?
Yeah.
The
absolutely.
panda, where their breeding cycle will go, like a pregnant panda has a different bamboo diet. It eats a different type of bamboo than they would eat when they weren't pregnant, and they like travel seasonally and want different types of bamboo. Like, it's a much more complicated web of food. May all still be bamboo, but different types of different places of bamboo with different nutrition at different times of year under different conditions.
Yeah. And also maybe this is just why they're bad at mating at all, is because they're not eating protein.
Right. Exactly.
That's probably why they're bad at math.
Yeah, for sure. Yeah. So
that's not, I don't know if that's, I say this as though everybody remembers the story we did in 2008 where they gave beef to children in one study and versus kids in the region who didn't have, and their math skills improved with a high protein. The girls had better math scores if they had a higher protein diet than their other, which I guess I think it was the only one who remembered that story.
Nope.
Yep, I lost that one. There have been many stories over the years.
We've had some stories. So
this is interesting stuff, though. It is your conservation aspect. I love that, and the interesting aspect of the trade-off, the energetic needs versus the dietary needs.
Yeah, and then there's this whole other human element of it too, where maybe this could be diet. Well, I mean, we know diet and sex drive are related in humans. We know that. And so this could be something that that could have implications with humans too. I mean, cockroaches and humans are pretty different, but it does raise a question that could have many areas of interest. There you go.
What else you got?
Oh my goodness, I have Hawkeyes, or I wish I did, because a new study from Lund University in Sweden looked at Harris Hawkeyes, and they found that they have amazing color vision. Yeah. So this is looking at why hawks and other birds of prey are so good at hunting by sight. The birds of prey like falcons and hawks, they hunt pretty much entirely by sight. And their visual acuity is amazing. And it kind of defies previous logic about how vision is related to eye size, and eye size is related to body size, large body, large eyes, small body, small eyes, larger eyes, better visual acuity. But as we often talk about on the show, size is not always the most important thing in the way adaptations work in the wild. In this study that was actually done in France, because apparently falconry is forbidden in Sweden, which just raises more questions. But anyway, falconry
got out of hand. It was like a fad. Everybody was getting falcons for Yule time one year, and just ended badly.
So because of that one time, falconry can't happen in Sweden where Lund University is. So they had to do this in France. And they had hawks in enclosures where they could fly to one of two perches within a bird enclosure. On one side of the enclosure, they projected a uniform color on a large screen. And on the other side, they projected a multicolored grid pattern. They trained the birds to fly towards the uniform color. So this way they were making sure that they recognized the grid and did not go for it. So there wasn't a question of, oh, they prefer this grid to that grid or anything like that. We're just seeing if they can tell the difference grid, not grid, go to the not grid. And if they went to the plain color, they got a reward. They gradually changed the grid pattern's contrast. This is the problem that I have is contrast, and closed the distance between the grid lines until the hawk could no longer see the difference between the plain screen and the grid screen. And they found that these guys have perhaps the best color vision in the animal kingdom.
Wow.
Yes. So they think now, best color vision, it's not about the ability to see small things. It's about the ability to see the contrast.
Mm-hmm.
So their contrast vision is almost 10 times better than ours. And this is what allows them to see things from so far away. So they can see things from twice the distance compared to humans. What's interesting about this, besides just realizing another reason that hawks are really cool, is that birds of prey have problems in our human world, including wind turbines, tall structures that they can't see, problems with windows. These are all things that affect the bird of prey populations in the wild. And if we understand how they see better, then we will better be able to make these structures identifiable to them so they'll avoid them.
Yeah. The thing about the wind turbines that gets me so much is they have great vision. I understand the songbirds maybe getting smacked by a wind turbine, right? Little bird, big blade, moving fast. But the hawks and birds of prey who supposedly have this really accurate vision, how is that, why do they still succumb to it? So it's not really the acuity, it's probably the I don't know, just the speed they're able to pick it up. I don't know.
The other thing is, what windmills are these? Like, even the big windmills that I see out in Benicia, where the wind always blows and the trees grow at an angle, they're not moving that quick. It's not like a fan. It's not like flying into a fan. They don't seem like they're moving at a dangerous clip? Like maybe is it smaller ones that they're running into and not the really big ones? I'm very confused
No, it's
by
the
this.
big ones. It's very hard for me to picture it too. Picture kind of like a bald eagle just flying straight into a wind turbine. Yeah, it doesn't make sense, but it happens a lot. And the better this is exactly how we figure out why, is by understanding how their vision works. So I think this is really exciting news, and that hopefully this will lead us to better protections, because we talk about it on the show all the time. Alternative energy is the future. And to
Just
say
not for birds.
To say we can't have wind turbines and we can't harness wind energy because of the birds of prey, now we're cutting off our nose to spite our face, and it's this whole push and pull of, if we continue to use fossil fuels, then there will be no wild spaces for the birds to live in anyway. So how can we reconcile these two problems? And this might actually be at the heart of it.
I never understood that phraseology.
Yeah.
Like, cutting off your nose to spite your face. Like, I don't understand it. Like, that's not,
I'm going to get rid of my nose. I do not like my face. I will get rid of my nose.
Yeah. It's like if you have a really ugly nose and you say, well, fine, I'm going to cut it off. That's still, it's worse. You should have kept your nose.
Yeah. And your nose is beautiful. Like, warts and all.
Well, thank you. Thanks. You like my warts?
Oh my goodness. Yeah, and I think I read something recently, speaking of wind power, that Germany is looking to up its wind power percentage to something like 60%.
Yeah, they're over 40, right? They're
over 40 now, and they're going to get up to over 60 by 2030, before 2030.
That's awesome.
For their whole country. It's amazing. And so this is important, because this is what a lot of countries are looking at. It's a possibility for many nations. Wind is a thing. It blows all the time. Let's figure it out, people. Also, I'd like to know how to be a Hawkeye. Can I do that?
Yeah. Just pop them right in there. Pull out yours. Pop those right in there. You're good to go.
Get my Hawkeyes. Good to go. Are we going to take a break, everyone?
Yeah, let's take a break.
Yeah, we probably should.
Let's take a break. All right, you guys. This is This Week in Science. And we will be back in just a few moments with more This Week in Science. We have so much more science coming. Stay tuned.
Can't explain things you've heard more than intuition. A lot of reason shows the way to go. New conclusion. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see. The answers lie somewhere.
Everyone, thank you so much for listening, for joining us for This Week in Science once again. And now is the time where I ask you to take part in supporting this show and keep it going. You can do that very easily. First, by heading to TWIS.org. TWIS.org is the portal for all things TWIS. We have things linked there, so you can find them if you forget how to Google things. But if you head to TWIS.org, first things first, if you haven't subscribed, or you know somebody who needs to subscribe, who would like to subscribe, get them to click on that orange subscribe button. You click on the orange subscribe button at TWIS.org. You'll have the opportunity for the three majors: Google Podcast Play Portal, iTunes, and YouTube. Makes it really easy for you to subscribe to those outlets. If there are other ways that you'd like to subscribe, there is a little note in our header bar. It says subscribe, and it has instructions for where to find our RSS feed and all that fun stuff. You can also just Google us. We are all over the place in the major browser search engines. So, how do you support us some more? Well, one fun way is to head over to our Zazzle store. The Zazzle store is where you find t-shirts and bag tags and pillows and all sorts of things, that many of them have the TWIS logo on them for easy advertisement of TWIS and your love of TWIS. And people can say, what is that? That's TWIS. It's my favorite coffee mug in the morning. And then they'll say, what is that? And you'll be like, here, come check it out, subscribe. And you can help share TWIS. The other is it's just wonderful art because Blair has made a number of beautiful art pieces for her Blair's Animal Corner calendar that comes out every year. I think she's almost ready for this year's calendar. Oh, she's giving me the thumbs up. It's super exciting. So the new calendar will be coming soon, but the old calendar art, you can find it on various items throughout our Zazzle store. So if you're into artful pillows or mouse pads that are also TWIS related, check out our Zazzle store. You click the Zazzle link at twis.org and it will take you right there. Other ways you can donate, support us, specifically by donating. Click on the donate buttons that you find on the main page and on each show page. There's a yellow donate button. It's for like a one-time donation. If you want to just donate right now, just send us $20 right now. You can click on that yellow button. It'll take you through a PayPal interface. Donation done. If you would like to support us on an ongoing basis, you go to the most recent episode, listen to it, go through the show notes with all the interesting links to things, look for the pink buttons at the bottom of the page, and these allow you to donate in a recurring fashion through PayPal. Don't like PayPal? Well, we also exist on Patreon, and you go to the header bar, click on the Patreon link. It should take you straight to our Patreon page where you can choose your level of support. There are multiple levels. And if something that's pretty easy, if you like us as much as a cup of coffee, I really would suggest the $10 a month level. That's $2 an episode-ish for 4 to 5 episodes a month, right? About $2 an episode for a pretty fun couple of hours of discussion and science and interaction. And we will read your name at the end of the show. We will thank you on the show personally for that level of support. So it's pretty easy, pretty straightforward. Once a month, $10. There you go, if that's something that sounds fun to you. But peruse our Patreon page if that is something you're interested in, or just subscribe, go through twis.org, whatever. Your support is what keeps this show going, because we actually do rely on your donations, on your purchases, on you to keep doing what we do. So we really couldn't do what we do without you. And we thank you for all of your support.
Can't explain things you've heard more than intuition. A lot of reason shows the way to go. New conclusion. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see. The answers lie somewhere within.
And we're back with more This Week in Science.
We are back. We are back. And it is now time for that segment of the show that we know and love as This Week in What Has Science Done for Me Lately? Let's get higher and higher on that. All right, everyone. This week's letter is sent to us. Let's make sure I can pull down the scroll here. This week's letter is a wonderful letter from Jorj. Jorj writes in, and Jorj, I'm sorry if I am pronouncing your name incorrectly. I apologize for this. He says, "Hello, TWIS. Just over 2 years ago, I woke up early one morning with pain in my abdomen. The pain worsened rapidly, and my wife decided a trip to the emergency room might be in order. By the time we had completed the half-hour trip, the pain was so bad that I was rocking back and forth while moaning constantly and simply trying to cope. The staff at the hospital did an excellent job of getting the pain under control and proceeding with a diagnosis. 7 hours later, I was undergoing emergency surgery. Turns out my bowel had twisted and blocked itself by itself. I found out later that this was, in my case, extremely rare. It generally only happens when there has been previous abdominal surgery where the bowel can catch on the scar. My belly had been a surgical virgin until the knife hit it that afternoon. I also found out that later that the injury is very time sensitive. The bowel can go into sepsis after as little as 12 hours. This is bad, very bad. I now realize that for 99.9% of human history, I would have experienced a very slow and agonizing death. As it was, thanks to the expertise of the medical staff, I left the hospital 2 days later with a few stitches and a prohibition on lifting for a few weeks. So what has science done for me lately? Well, there's that. Plus, of course, smartphones, safer vehicles, virtually unlimited access to information, HD television, instant communication, streaming a healthier microbiome, pictures of Pluto, productivity, instant banking, cleaner laundry, TWIS, a chance to feed the world, a career, racing simulators, longer life expectancy, never washing dishes, video games, some control of my cognitive biases, podcasts, robots, more accurate weather forecasts, world travel, knowledge. Thanks for a very entertaining and informative show. Please keep up the good work. Jorj, thank you so much for your letter, and I'm so glad that medical science allowed you to not go into sepsis and that you are with us today. It did not go through an agonizing death. Much happier being able to read your letter aloud to all of our listeners. And I love your list of all the things. All the many things and I did emphasize things myself, like not watching dishes ever again. I love my dishwasher. I really do.
It's so good.
It's so good. Dishwashers are, yes, they are one of modern science's best inventions. But, being able to save people's lives is pretty huge. So thank you for writing in. Really appreciate it. Thank you for sharing. And everyone out there, if you are interested in sharing your own stories of what science has done for you lately, send me a note. Email me, Kirsten, KIRSTEN, @thisweekinscience.com. Or a message on our Facebook page will do. That's the This Week in Science, facebook.com/thisweekinscience. That's our Facebook page. Send us a message if you do the Facebooking. And we would love to hear from you and keep this segment of the show going. Justin, you got some science news for us?
Okay, yeah, this is archaeologists a while back. Oh gosh, when was it? I think this was 1960s when this was initially found. But they recovered 13 human skeletons and the remains of 3 horses that were pretty well preserved. And these were the remains of high-ranked warriors in an early medieval cemetery. And they have now undergone DNA sequencing. So this is a group of Germanic tribespeople that were somewhere spanning regions of Germany, France, Switzerland, and Austria. This particular grave site is in Germany. They were the Alemannic people. And I guess they have these 13 individuals were uncovered from 12 different graves. 11 of them were likely male. They're pretty sure. Something between the morphology, the bones, and the DNA suggests so anyway. So that suggests that the burial rites were sort of for the guys. That's who got buried. That's who was predominantly the warriors. But in that, some of them also then were likely female. The plots were sort of interesting about this too, is that they had individuals here who were likely from Northern and Eastern European populations groups originally. 6 of the individuals were. 2 of the individuals who were not related to each other were most similar to modern day Mediterranean people. So this kind of is pointing to a Germanic tribe that was pretty diverse. These are I think it's 5 of the individuals were closely related to each other, and they did some strontium and oxygen isotope contents of their dental enamel suggested that those people were born locally. They were born there and they died in the same region. Well, the others were born kind of from far-flung places. So, yeah, the ancient German people were from all over Europe in these tribes. It was also interesting is that they found the artifacts they found were of different origins. So this is a diverse people with who were also trading diversely and covering a lot of territory in their lives. Not really what we would have expected. You consider these ancient tribal societies and you think, the hill people, they were born and they die up on the hill. They're in the hills. The valley people are from the valley, they die in the valley. And it wasn't until some sort of more modern advancements took place that people began to explore the world. No, these people were culturally diverse, ethnically diverse, and we're family to each other as well.
Doesn't this sound like so many of the stories that you've been coming to the show with recently, where it's the copper in this indicates that they were trading back and forth, the maybe not so much genetic or the DNA evidence, which this provides, but there have been like those little tidbits of showing that, I think there was a story recently where women were moving from place to place, like, and just like animals.
Well, they were. That was the coin of the day.
Exactly, right?
How many women will you give me for this guy? No, I'm joking. Well, it might be true. I don't know. I wasn't there. But what I think is really interesting about this is a couple things. One is we typically have looked back at history and said, aha, these are Byzantine artifacts. These must be Byzantine people. These are Frank artifacts. These must be Frankish people. We have 2 different types of artifacts here. 2 different peoples must have fought over and settled the land at different times. And here's an example of burials, of family burial plots, where the people and the artifacts, now we know, are from far-flung places. And so this Germanic tribal culture that was spanning quite a decent territory, and these are also Celtic. It's part of that history as well, which is also something that we are now finding, or have in more recent years sort of realized that the Celtic culture expanded across cultures and peoples, and was much larger and wider ranging and lasted a lot longer than we might have thought, and that their technology actually led to inventions that the Romans copied. So they weren't this barbarian people quite as painted by the Roman conquest. But I do love the fact that now that we have DNA that can show Mediterranean bloodlines in Germany, shows one, that people would travel great distances. People would accept each other and their different traditions and would take them on. I like the way that you make hats. I'm going to make my hats that way now too. Or I would at least like to trade for the hats that you made because they're awesome. Right?
Yeah.
Versus a lot of the traditional histories that also, I think, lead to traditional misconceptions of who peoples are, or where peoples come from, or what it means to even have a historic tradition of a people in a place. So it's fascinating to be able to to get the insight from DNA analysis on this, which adds another layer to our understanding of the past.
Yeah, I mean, it definitely also puts some interesting context on the very old and unfortunately more recent conversations about genetic purity and pure lines and all this kind of stuff.
I don't know if are those recent, because I feel like those ones are the ones that are old and have been disappearing over time. But I feel like those are old conversations.
They're not all gone. But the point is, there's no such thing. There's these clear lineages and ideas of keeping things culturally isolated, and it's all just
that's right. That's sort of it seems that like that's the new tradition, is pretending that your traditions are all your own. Whereas they were Patrick, if you're listening, as a one of the longest time listeners to TWIS, friend of the show, considering we've gotten to meet him, and he's I think a friend of ours, all of ours at this point. He's from Ireland and has an odd take on Irish Americans, which is, it's so odd how sort of into being Irish they are, and how completely different that is from anything that's in Ireland. So people create these sort of fantasies of cultural identity too that they really grab onto. But it's nice to know that historically, and it makes sense, because how far could humanity have gotten if we were constantly, and the concepts that I think you're getting to, or the concepts of otherness and xenophobia, aren't really unique to any one culture. There's people of every culture who think other people are the others, right? There's nothing that makes you uniquely or idealistically. There's no American ideal of the others. There's no German cultural ideal that everyone else is another, because really all of that exists. That xenophobia exists within some people everywhere. That's the one thing what we all have in common. It's one of the things. I think we have more, but to know that in the past, they would have no idea that the children's children would think that they're other than Mediterranean, because they have Mediterranean roots, as well as Germanic, as well as Scandinavian, as well as everything else. We're all one people, man.
We are. And the one thing that I just want to highlight, when research like this comes out about our past, our history, our culture, there are places that hold this information. And we need to fund these places to make sure they are maintained. Yeah. We talk on this show all the time about science that is done in the stacks, when drawers are pulled open by graduate students and gone through to look for something different. New things have been found, old things have been discovered, and they would not be there if the museums, if the institutes, the research facilities were not there. So the funding of science for our own cultural history is essential.
Yes,
and I'm bringing that up in light of the massive museum fire just this last weekend.
Yeah, they had a $13,000 a year budget to maintain the thing.
Yeah, this is Brazil. It's a beautiful, cultural, wonderful place, a land of indigenous peoples, where the study of linguistics has been ongoing. Complete loss of the study of some of those peoples and their languages over the last 200 years, because budgets were cut.
Although I will point out that I keep hearing it touted that the Americas' oldest human remains, or ancestral remains, or America's oldest human remains lost in Brazil museum fire. Well, they're not, but they're old, and at one point they were identified as such. We have we go back more than 11,000 years in the Americas. We have much older human remains that we found. But
that doesn't matter. It's the loss.
It's the technicality, I guess. It's still a loss.
And we are all everywhere. You know, these bones that they looked at, I'm looking at the study, they were discovered in 1962. And they're just now getting around to looking at the DNA. They've been sitting and waiting for the technology and the people to come together to make it happen in a place, you know, where they could be safe. And so this is something we need to consider around the world. It's not, funding science is important, but funding our museums is essential for all our cultural knowledge to move on and perpetuate and influence better thinking in the future. Yeah, I just had to say that. I had to get serious for a moment there. Let's get into, can we get into some plants?
Yeah.
Yeah, I've got some cool stories about plants. Australian scientists have managed to create they've put things together. They've used blue-green algae and took a component of blue-green algae and stuck it into crop plants. I think right now, you know, they're still really just looking at, they say crop plants, they're meaning like wheat, cowpeas, cassava, things that people are surviving off of. The research right now is probably just being done on tobacco plants because it's a very major research plant. But what they have done is taken a compartment from these plants, which the plants use to take carbon dioxide and turn it into sugar very efficiently. And so this blue-green algae, cyanobacteria, who use carbon dioxide, they take it up and they photosynthesize, and they are primary producers on the planet. This is the first time researchers have been able to take this little machine from the blue-green algae and incorporate it into plants with the hope that it will absolutely make plants better producers, that plants will use more carbon dioxide to create more biomass that will feed more people more nutritively. And
but didn't we last week say that when plants grow bigger from higher carbon dioxide levels, they don't contain more nutrients?
Right, but that has to do with plants in their current state and the way that they currently use carbon dioxide, which is not as efficient as the cyanobacteria. And this little bit of a machine that's called a carboxysome, and this little bit could lead to a 60% increase in growth and yield. So it would be, it'll allow the plant to function more efficiently. So yes, the size would be getting bigger, like we were talking about. Carbon dioxide already tends plants toward getting bigger, but to do it in a way that uses carbon dioxide more efficiently, creates more sugars for the plant. This is going to be something that can, it'll concentrate carbon dioxide, which is something that it would be very useful for plants as food. So we'll see where this is going. This is one of the neat things from the director of the facility, Stephen Long, Eikenberry Endowed University Chair of Crop Sciences and Plant Biology. He says, when we supported this research starting 5 years ago, we knew this was very high risk, but we went ahead given the very great rewards that it could lead to. And we never expected to see carboxysomes in the crop chloroplast by this stage, maybe just pieces. So by assembling carboxysomes indistinguishable from those of cyanobacteria is a spectacular achievement and puts us well on the road to be able to achieve the full system. So they're pushing forward. This isn't the only step on the route to creating plants that can deal with the future atmosphere and future population needs, but it's a very exciting step forward. And meanwhile, on a quick note here, NASA has started a carbon dioxide conversion challenge. And in what they're trying to do, this challenge is a public competition seeking novel ways to convert carbon dioxide into useful compounds, hoping that we'll use such technologies to manufacture products using local indigenous resources on Mars that can also be implemented on Earth by using both waste and atmospheric carbon dioxide as a resource. And that is something that is opened up now to people in the United States. Phase 1, teams must submit a design and description of a conversion system that includes details of the physical chemical approaches to convert carbon dioxide into glucose. Australian National University, you need to move to the United States. You're already doing it. Anyway, NASA will award up to 5 teams $50,000 each, and that will be announced by April 2019. Phase 2 is the system construction and demonstration stage and is contingent on promising submissions in Phase 1 that can have a viable approach to achieving the challenge goals. And the end purse of the whole challenge is $1 million.
I feel like their goals are swapped with what they should be. They should be worried about Earth first and then Mars. But I'll take it.
Yeah, it's kind of like, we got spam and Velcro from things heading towards space, right? And so
wait, what?
Things here.
No, we did not get. That's not where we got Velcro. We got Velcro from a Dutch guy who was getting thistles in his socks, and then his dog, I think, or his goat. You got a goat or a dog.
Well, okay, maybe I misspoke on that, but I didn't on spam.
Okay.
We have freeze-dried ice cream now, also.
Yeah. We have the ice cream of the future.
So many technologies come from our looking outward and can be used sustainably here. But I get your point. I get your point. How about we just use it here? Yeah, it's great. And then finally, for this plant aspect, more algae than plant on this other study. Researchers at St. John's College at the University of Cambridge in England have used semi-artificial photosynthesis to try and produce and store solar energy using sunlight to convert water into hydrogen and oxygen. So when I say semi-artificial, we've talked for years about wanting to use the power of the sun to split hydrogen into oxygen and water split water into hydrogen and oxygen. Get that one backwards there. And for years, it's depended on elements called catalysts that speed up reactions and make particular reactions get enough energy into them to actually happen. Because usually, if you put different molecules and compounds together, they just kind of want to hit an equilibrium and just kind of stay where they're comfortable. And so you have to kick something into them to kickstart the energy to make the chemical reaction take place. And so catalysts in these hydrogen reactions have been a critical part so far. And we've talked about many different researchers, copper ones using lots of different compounds as catalysts. The problem is they're expensive and they're hard. They're not easy to come by. And many of them are toxic. So they're not great for the environment either. So the sustainability of them is really limited. And so these researchers who just published in Nature Energy, they're trying to use nature's components to do this. And in their new paper, they took a hydroxylase, which is an enzyme. It's kind of like a catalyst, but for biological reactions.
Yeah. Almost the definition of a catalyst.
Yeah, so they've used hydroxylase from algae and shoved it together with photosystem 2 from plants and some other engineering components. And they have a system now which is splitting water and it's creating hydrogen and oxygen. And they say that they're very excited that they can selectively choose the processes they want. achieve the reaction they want, which is inaccessible in nature. And it's also been difficult with the catalysts we're trying to get. And so this could be a great platform for developing solar technologies. The approach could be used to couple other reactions together to see what could be done, learn from the reactions, and build more synthetic, more robust pieces of solar engineering technology. But they were able to split water into hydrogen and oxygen. They were able to, for the first time, take these biological components, the hydroxylase and the photosystem 2, and put them together with other elements and bypass having the need for a catalyst in this reaction. So we'll see where it goes. I think this is a very, I think it's a promising step, personally. Cheaper, easier.
Cheaper, faster, better.
Not toxic on the environment.
Always a plus.
Better.
Always a plus. Better all the way around. Yeah. So new, cool energy. I haven't talked about a lot of energy research on the show. Justin, you've brought it up a bit more, but I've just kind of like kept it at arm's distance because it was so promising for so long. And we've had so few really, really good things pop up. But I think it's starting to come back again.
Yeah. Of course, the problem is funding, which we talk about constantly. Although, you know, as we've been talking about this, when is this coming? There's a lot more solar panels on roofs than when we started this show. It's become common to see them. It's not like, oh, look, solar panels on a roof. It's now, yeah, this neighborhood all has solar panels. The solar panel salespeople must have done a good job in this neighborhood when they were canvassing. This is, I got a story here. This is analysis of fatty residue found in pots along the Dalmatian coast of Croatia. And so a few weeks ago, 3 weeks ago, something like this, we talked about how bread got pushed back by about 4,000 years. Turns out we had bread before we had farming. They were making bread out of wild grain before we had farming, right? In this, they're finding what they think are fermented dairy products, soft cheeses and yogurts that would be about 7,200 years old, which pushes back cheese making by 4,000 years.
Again?
Yeah. Well, no, before it was, the other one was 4,000 years for bread, going further back. This is cheese 4,000. Now it's not, the bread made it back like 14,000 years. So if you wanted a slice of cheese on that first piece of unleavened bread out of the clay oven, you had to wait 7,000 years. Okay. So cheese was in the far distant future. Okay. Back then. But 4,000 years earlier than any other evidence that we've had of it today. They found milk in these pots as early as 7,700 years ago, which is 500 years before they had figured out that you could ferment it. What's interesting, though, too, is that right around and soon after sort of the invent of cheeses, the pottery of the culture changed considerably. And a lot of the pottery was designed around making cheese. Cheese was a hit right off the bat. Like as soon as people had cheese and yogurt, they're like, this is good stuff. We need to keep making more of it.
Cheese.
What's sort of interesting here too is that the adults of this region thought to be lactose intolerant.
What?
But children remained tolerant till, into the tweens, 10 to 13, something in there. So this was something definitely that the children were utilizing initially quite a bit. And then, as I think we've talked about on the show, there becomes a transition into more lactose tolerant society, right? Because, as I think Blair put it, nobody wanted to date the flatulent girl. There's a sort of flatulent.
Did I say that?
Yes. There was like a flatulent selection that may have taken place.
That sounds like me, I guess.
Mm-hmm.
Well, that's great. Croatia, huh? So that's I have some roots in Croatia. No wonder I love cheese so much. It's in my
Dalmatian
blood.
Coast. There's now the birthplace of cheese and yogurt.
That is so cool. Yes.
Yeah.
Push it way back, and then we look at the genetic the mutations that allow it to be digested. Put it all together. Put it all together. I want to jump to our quick science stories and get us to the end of the show, y'all.
Yeah.
So, yeah, I've got a funny story about monkeys. Yeah. So, in vervet monkeys, a study that was just published in Current Biology, tried to find out who monkeys are learning from. And so when they're learning about foraging, who are they following around and who are they learning from?
Yeah.
What they found is that guys learn from everybody. They're just indiscriminate about who they will learn from. They will learn from if you're doing good foraging, I want to be following you. Doesn't matter. I want to be following the good foraging. Females, though, sit back and say, I'm going to go follow my lady friends. I'm going to follow my lady friends. Even if there was a better male forager who she could have learned more from, she stuck with her ladies. And so what they found, what they think was going on is that in this sex difference in kind of who they're learning from, is that it has to do with social ties and bonds, because the females in these groups of monkeys stay with the monkeys. That they stay together from when they're born into the group. They die as a part of the group. It's very rare for the females to leave the group, whereas males leave the group and move to other monkey groups. And so for the females, they think it's very important to maintain that social structure and that bond through learning, and and that the males maybe are not considered as trustworthy or as close a part of the group because they're coming from other places into the group at different times.
So you want advice when you move to a new town from someone who's been there 10 years, not 2.
Right.
Basically.
Yeah.
So the ladies know what's
Yeah.
up because they've been there literally since they were born.
Yeah, they've been there their whole lives, and you don't know if a male is going to be kicked out, if a male will be, they get excommunicated all the time for one reason. They have a fight, another male monkey becomes dominant, and suddenly they are made to leave the group. These things happen, and if the female, the ladies, they're like, I'm just gonna stay with my ladies, and so that's who they're learning from.
Yeah.
That's a little bit limiting, though, isn't it?
It does seem a little bit limiting, but in terms of maintaining the social bonds that are so important for child rearing and for feeding in general and making sure that the group is strong, it may actually be more important in the end. It might be better for the group, for individuals to maintain the social bonds than for each individual
So it's like a division of labor.
Try and go for the best,
of intellectual labor.
Yeah.
Yeah.
Yeah. Yeah, the group does it. Well, anyway, yeah. Ladies, they be following the ladies when it comes to learning, and the vervet monkeys.
Well, it turns out also fish be knowing fish. Is that a decent segment?
Fish know thyself.
Yes, fish know thyself. So we've talked about the mirror test in the show previously, the self-awareness test from the 1970s. Chimps, bonobos, orangutans, dolphins, elephants, pigeons, they have all proven to pass the mirror test, which is when you put a mark on a creature's face and introduce them to a mirror. If the animal makes attempts to touch or move where the mark is, then that means they know that that thing they're seeing in the mirror is themselves and they're touching here. We've recently, I think maybe 6 months ago, talked about how research has proven that this test works for some species, but for other species that don't understand how mirrors work, for example, this is problematic. For an animal that doesn't have opposable thumbs or a way to clean themselves, problematic. But it still is helpful in some cases. And now, for the first time ever, we've seen some fish that potentially may have passed the mirror test. It's a cleaner wrasse, a tiny tropical fish. Researchers placed specimens in a fish tank with a mirror, watched what happened. They're territorial. So at first, the fish behaved as if they saw an encroachment from their territory. They tried to attack their own reflections. But after they equalized the mirror a little bit, they found that the fish were bobbing as if watching themselves, they say dance, but really just move. They were watching their movements and seeing how the reflection moved. And then they used a gel to mark their foreheads that they could only see when they looked in the mirror. Some of the test fish spent time looking at the reflection and then trying to scrape their face where the gel was.
Wow.
As if trying to remove it. Now, this sounds at first pretty promising. However, the cleaner wrasse does have the normal behavior of cleaning parasites off one another.
And if it feels this gel thing on it, then...
Yes, but then the part where this still has me is that if they thought that the fish in the mirror had a parasite, they'd start trying to peck at the mirror. But they didn't. They looked in the mirror and then they tried to scrape it off on something. So it sounds good.
Yeah. So I was teasing out that I had it's now gone because it's a tropical fish. They don't last long. But I had a fish that was pretty aware of the surroundings outside of the aquarium, which is when I would lift the big yellow food container, it would right up to the top. It was like ready, like, okay, it's time. Like it was like if you rang the Pavlovian bell and the dog salivates, you lift this container up and the fish is ready to eat and knows it's coming.
So that's definitely awareness. That's awareness of things around you, but it's not the same as self-awareness.
Yep.
And so that's kind of this line that we have very systematically tested in species and said, you understand what you look like and how to identify yourself, and you do not. I'm guessing just like with animal communication, and we said, oh, this animal can't communicate, and this animal can't communicate, and this animal can't communicate.
And then every
turns out they all can.
Blair brings a story that says quite the opposite.
I'm going to guess that a lot of animals, particularly animals with intense social structures, have self-awareness.
Well,
we're trying to find how to test it, right?
Yeah, I think if you can show it in fish, I mean, that's to me, the fish in general, to me, is sort of the standard for intelligent animal life. Like that's where all of this came from. It started as fish, right?
But see, you could go backwards even further. I think you could go to invertebrates who, now this quick science story is getting very long, apologies. But invertebrates show altruism, right? And I would argue that altruistic behavior is based in self-awareness. Because it's this idea that you help one another, is that a communal win is a personal win. And that, to me, doesn't make sense unless you have some sort of self-awareness.
Actually, it makes more sense if you don't have any. If that other isn't any other, but it is you, right? Like if you're feeding your community just because that's what it needs food. Like I need food. It's the same food. It's the same me. That's all me. They all look like, I think the first thing about the mirror test is that would occur to me is like what they did was great. They got these fish used to seeing themselves in the mirror. Because my first initial sort of was like, how does the fish know? Like the fish looks in the mirror and goes, Oh, that's me. Oh, I have a dot. I didn't know I had a big gel dot on my forehead.
Yeah.
Huh, look at that. Oh, there it is. Yeah, that's what I look like. I had no idea. Never seen a mirror before. Right. But the fact that they could differentiate, or potentially could differentiate what their normal look is versus that. I think that is pretty good. That's pretty good.
There's a big question though in the motivation of an animal for doing something. There could be there's just an internal drive to go eat something when you're hungry, but you might not be self-aware of the fact that you're hungry. And there is a slight but very important distinction there. And so this is you could see maybe your little fins. All animals have, well, not all, but animals, many of them have pain receptors, right? Fish, these wrasses, they have pain receptors, so their body can respond to harm because their body needs to protect itself. But does that mean that the fish is aware of the fact that it was hurt?
Well, this is that whole conversation, though. Then again, like, because you brought up hunger, like, why do humans don't go? Logically, I ate it 8 o'clock this morning.
Sometimes we do.
And
sometimes we do. Sometimes
it's now
we go,
approaching 5 o'clock, and I skipped lunch. I should add nutrition to the body system so that it continue to function. No, you're like, oh, why is my stomach? Oh, yeah, I didn't eat lunch. Oh, I gotta go eat.
Exactly.
Like, we still have.
It's yes, and we respond. And we catch balls without thinking about it, or jump out of the way of a truck. We do things because our sub or unconscious mind acts on things and knows about stuff, but we are self-aware of our motivations, of what we're doing, how we're feeling. Well, we have to. Some people, we have to work on it. But it is a very this whole question of self-awareness in other animals. This is why it is so hard to test, and why it is so hard to disprove the hypothesis that an animal has or does not have self-awareness. And so this is why the question is, okay, this is the behavior of these fish. So since this is their behavior, are they really self-aware?
Right.
My theory that Blair is going to prove someday to be true, I think, is that all animals are self-aware, but humans are somewhat, not completely, but somewhat unique and probably more efficient than any other living thing at actually doing something about it. Like not being like sort of like being self-aware, but like, I'm hungry now I'm eating. I was going to put off eating till later, but I got hungry and now I have no choice. I think we are a little bit better about hacking all of those drives, reaction that you're talking about.
Sure, because we're self-aware.
But I think what's funny is how would it be to be?
They're conscious.
Right.
Are they self-aware? Are they?
Right. But my point is,
oh my gosh, this isn't a philosophical.
No.
This isn't a falafel program.
It's not.
I'm not being philosophical. What I'm saying is, what would it be like to be this self-aware and yet completely at the same time at the mercy of the animal brain urge, the brain overrides? Like, to be completely aware, like, oh, I didn't want to chase this squirrel. I had other plans, but I guess here we go. Like, that would be almost so awful.
It would be terrible. It would be like being taken over by one of those crazy parasitic funguses that makes the ant's jaws clamp down on my jaws are tightening around this branch, and I don't
that makes
want
that
to
much
do
more
this.
terrifying if there's.
I wonder if that's. Wouldn't that explain why a dog looks guilty while doing something that they know they're not supposed to do?
Yes.
Like, I know I'm not supposed to, but I can't. I'm not in control here. I'm aware that this is the wrong. I should not be chewing this chew and sneaking it outside the house, but I can't help it. There's nothing I can do to stop this. Right? You've seen this, right? But I mean, we all know this.
Sorry.
Like,
yes.
Yeah. But in the end, it does come down to that difference between, as Bleak is saying in the chat room, and is what I was trying to get to, responding to stimulus versus understanding psychologically what is involved in what you're doing. So it's an interesting question. So I'm going to say on this, based on this, jury's still out as to whether or not those fish are self-aware. That's where we are right now. I hope they do more studies. It's time for us to end this show. It's 10
Do
o'clock.
we have to?
Yes.
I missed all last week, so I'm like ready for more show.
Yeah.
I didn't...
Justin, I am very tired. It's the end of the show now. It's time for me to say thank you to my co-hosts for being awesome. Everyone in the chat rooms, YouTube, our main chat room at twist.org/live. Thank you for being here and chatting. Thanks to Fada for doing social media and show notes. Thanks to Identity 4. Oh, and also managing the chat. Gord, you're also in there managing chat. Ben Rothig for doing that. Identity 4 for recording the show so that we can have an audio podcast. All these people, you're all here helping and making this a better show. Thank you so much for that. And I also really, really, really want to thank our Patreon sponsors. Thank you to Paul Disney, G. Burton Lattimore, Richard Onimus, Ed Dyer, Ken Hayes, Harrison Prather, Charlene Henry, Joshua Fury, Andy Gross, Steve DeBell, Alex Wilson, Tony Steele, Craig Landon, John Ratnaswamy, Mark Mazzaros, Jack, Matthew Litwin, Jason Roberts, Bill K, Bob Calder, Time Jumper 319, Eric Knapp, Richard, Brian Condren, Aiden Jeff, Richard Porter, Jacqueline Boyster, Noodles, Kevin Reardon, Dave Neighbor, Christoph Zucknerek, Noah Zemke, Jim Seabright, Ashish Pants, Ulysses Adkins, Sarah Chavez, Artyom, Rick Ramus, Paul, John McKee, Jason Olds, Brian Carrington, Christopher Dreyer, Lisa Slazewski, Jim Trapeau, Greg Riley, Sean Lamb, Ben Rothig, Steve Lesseman, Kurt Larson, Rudy Garcia, Marjorie, Gary S. Robert, Greg Briggs, Brendan Minish, Christopher Rappin, Flying Out, Aaron Luthen, Matt Sutter, Mark Hessenflow, Kevin Parachan, Byron Lee, E.O. Mark, Tyrone Fong, and Keith Corsell. Thank you, all of you, for your support on Patreon. And if you are interested in finding out about how Patreon works, you can find information at patreon.com/thisweekinscience, or just go to twist.org. We've got a link to Patreon there. You can also help us out, give us support by telling your friends about TWIS. Sharing it is a big deal. On next week's show, we are going to be discussing the Tangled Bank, the Tangled Web of Evolution.
The braided
with David
string.
Quammen. With David Quammen. Yes, he's written a book and we are going to talk about it. And I'm very excited about this opportunity to, I think it'll be a fun interview. And what else are we doing? No, that's it. We'll be talking about science news also, because we do that too. And it's Wednesday, 8 p.m. Pacific time that we broadcast live each week. But if you can't make that, don't worry, because we also have twist.org and we've got YouTube, the places on the internets where the show is saved for perpetuity. Go to twist.org.
Thank you for enjoying the show. TWIS is also available as a podcast. You can just Google This Week in Science in your iTunes directory. Or if you have one of those mobile type devices, you can look for TWIS, the number 4, Droid app in the Android marketplace, or simply This Week in Science in anything Apple marketplacey.
For more information on anything you've heard here today, show notes will be available on our website. That's right, you remember, it's www.twist.org. While you're there, you can also make comments on those broadcasts and start conversations with the hosts or other listeners.
Yes, or you can just skip those people and contact us directly. Email Kirsten at thisweekinscience.com, Justin at twisminion@gmail.com, or Blair at blairbaz@twist.org. Just be sure to put TWIS, TWIS, somewhere in the subject line, or your email will be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
It's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. This week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma. Got the eye. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address. From stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. So how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you learned anything from the words that we said, then please just remember it's all in your head. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 This Week in 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 Science.
You're muted.
But I was being really funny too.
Oh.
Oh, yeah, the show's over now. Show's over. Show's over. Nothing to see here. Yes, tis the after show. Tis the after show. But I'm not going to stay here for hours like Justin might want just because he missed last week. Sorry, dude. What? Such mutage. Yes. Wait, there's a time, is there the time change is in Australia? Because it's not here, right?
Yeah, our time change isn't until November.
Is it November? Okay. I was looking and somebody was talking about having a time change and I was like, whoa. I just got back to school again with the kid.
No, ours is early November.
Yeah. I'm not ready for a time change.
I cannot wait to open the box that has the long cords. like the way
Oh,
I had to
moving.
create a tower of boxes upon which to put the modem, because it can't rest on the floor, because and I have to limbo under a cord to get over to the other side of the studio here, because I have somewhere like a 20-foot what do you call it, Ethernet cable. But I don't know where it is. I've got the one that's just barely reaching the length of cable that I could get to where I could position the thing. I was almost this far away. Well, no, further than that. I was like this far away from not being able to connect to the internet because of cables. And then I realized if I just lifted things up and kept a high line of wires running across the studio here, I can make
Gotta
it
figure
work.
that out for next week.
Yeah, hopefully by then a couple things will change. I don't know if the internet quality, it seems like it's been okay. But
It's been okay. I'd say your video froze a couple times, but your audio was never messed up.
So
I mean, it's kind of had some little blips in it, but it hasn't been bad.
There'll be a speed upgrade. We'll get the set put back together.
Yeah.
We'll hopefully get a cord that won't make me limbo across the studio.
Limbo across the studio.
Yeah, that doesn't sound very child-proof, Justin.
Oh no, not at all. The lighting is actually. I have done nothing to the lighting here, and it feels like okay. Like it seems like there should be maybe a light over there or something.
Yeah.
It's a little dark on the side of your face, but it's not terrible.
I'm glad the audio is working. That was for those. I guess the audience couldn't see it, but the sort of few minutes pre-going live, I had no audio. I had to do some settings, and I had a cable plugged in the wrong place.
That'd do it.
It was a combo, and so trying to fix one, taking the cable and putting it everywhere it logically should be like, no, this is it. Well, I'll try it here. Nothing worked, and then realizing there was also a setting problem that was making the cable switching totally pointless.
It does, yeah.
It kept switching cables all day long.
Nothing was going to happen.
Different ports in the storm. Nothing. How is this possible? There's only, and I did the right one first and last, but still.
Yeah.
Why does my computer have this many ports? It's too many. Also, I guess I don't know if the computer could be heard because of this configuration. It is up right next to the monitor, and it's noisy. Like I don't know. It sounds like it's defragging.
The fan, yeah.
It's not the fan. It's the. It's been like making like as if the thing was defragging. I'm like, it doesn't usually make this much noise. So there's other.
Bleak, I want to know more about where Bleak works. Are you seeing this whole narrative about how he goes to lunch and gets a beer from his job
and can watch us.
And can watch us. And he just said, peeps are back in the office, so I'm going to go get a beer. I'm trying to picture if it's just like there's a keg in the office and he's bringing a beer back to his table, to his like workstation, or if he's just like, see you in an hour, I'm going to go get a beer and I'll be back to work.
People are back in the office. I got to go.
Oh my God.
So, this was I think I've talked about this on the show before. This was my experience as an apprentice carpenter, I guess, for a few months in Denmark.
That sounds like a place where you should not be drinking on the job, is being a carpenter.
Well, you maybe would think, but it was like we were doing this one job, and then the electrician stopped by because the electrician had to run some wires. So we stopped and had a beer with the electrician. And so you pack beers with you for the people you might run into during the day. We went back to the headquarters, I guess, the shop, where all the other work people were. Stopped for lunch. Everybody had a beer. And
What percentage are these beers? Are they like 2%?
they are. You know what? They're not a California beer. They're I think
Yeah.
all alcoholic
Oh, man.
beers in Denmark are pretty low percentage. But then if we had the stinky cheese was brought to the lunch, then we'd all have to take a shot of schnapps with your stinky cheese. And then somebody else would stop by the shop from a different shop, and you'd have to stop and bust out a beer for them and pass out free beer. I remember I remember like one of the first days, and I mean this was over the whole day, maybe 4 beers. So a lot of beer to be drinking at work, I think.
Yeah.
But I was like, oh boy, I am really tired. No wonder these workmen come home really tired from a hard day of carpentering. This is hard work.
They're hungover
be
before
doing
they
while
get off
drinking.
work. Like they arrive home from work hungover.
Yeah, a little bit like I need a nap, and then
Oh my god, weird.
but yeah,
Bleak lives in Australia.
Yeah. Yeah. So they
just-
do things differently there.
They do things differently.
civilized.
I mean,
That's how
here
we used to do it.
in
Our
San
forefathers,
Francisco.
Founding fathers were drinkers.
Yeah. In San Francisco, a lot of the techie jobs have beers on draft in the offices and stuff like that.
I'm like, really? You're just gonna have a beer?
I just get tired, I think.
I do
it would, it would really kill my work ethic.
I know. I'd be like, it's time for bed.
Yeah.
Yeah,
It's just like that.
I got taken out for a lunch, and there were beers. And the second half of the day, I was not as productive.
Yeah.
I would not recommend this as being. Well, I don't know. Then again, I have a lot of I got a good friend of mine that owns a brewery, so that's a little different maybe because then it's the job. It's on the job.
Yeah.
A lot of beer. Have somebody come from another brewery and you have them taste some beers, you take the beer with. So I get there's certain professions where it just makes sense to be having a beer at work because that's what you're doing.
When I was in Lexington, Kentucky, we toured a bourbon factory. And I guess part of the process is you have to taste the Mad Dog. The Mad Dog is basically moonshine. And you have to taste it and like make sure the mix is just right before you turn it into bourbon.
Yeah.
And can you just imagine having to drink moonshine at your place of work, but also being good enough at it that you can tell distinct differences in what to me tastes like rubbing alcohol.
Right.
Like,
You don't have to drink it though.
no, you can spit it out.
You can swish and spit.
Yeah.
You don't have to drink it. Good.
Yeah. But it's pretty high proof. So I feel like some of it's still getting through all the, the vasculature in your mouth.
Exactly.
Still get a little bit of it. Yeah. All right.
Yeah, a lot of people think it's about the taste of the moonshine of the Mad Dog, but really, the only way to calibrate proper Mad Dog is the warming sensation in the belly. That'll tell you all you know.
Yes, identity for it. David Quammen. I went to the wrong mouse. David Quammen. Yes, the Tangled Tree. I said the Tangled Bank because that's another picture. But yeah, the Tangled Tree, that is the book Quammen has written, and the guy that we're gonna be interviewing next week. He's written some good books.
Yeah.
It'll be fun.
I have to correct myself. I just looked it up. I was like, is it called Mad Dog? It's called White Dog.
Oh, White Dog. Mad Dog is Mad Dog 2020, or think.
Yeah.
Yes.
So White Dog.
Nobody, you don't want to drink that at all.
What is the proof on White Dog? I want to look. 90 proof.
Oh, that's nothing.
That's
White.
nothing, huh?
That's just the flavoring. Wait till they add the alcohol.
Oh,
just
that'll be
the-
nice.
yikes.
Identity, wine, and I'm gonna go visit Identity 4 at work someday when he's bringing wine. I guess. I mean, I work at home. Does that count? I mean, I guess I've got a stash that's called my liquor cabinet.
Oh no, I'm sorry. White Dog is 120 proof.
That makes more sense. That
Yeah,
makes
yeah,
more
yeah,
sense.
So this white
It's
dog that I
burnable.
tasted, this white dog that I tasted in Kentucky is 120 proof.
That makes way more sense.
But most other white dogs on the market are watered down to 80 to 90 proof. Wow.
Because they're on the market. Yeah. Because what they're doing.
I could have bought this if I wanted to.
Yeah.
This 120 proof. I wouldn't have. It's we did a tasting and I tasted it and it almost came right back.
Ooh.
And I apparently made a face. It was completely visceral. I didn't do it on purpose, but this like very tough looking guy that was like had this giant beard and was wearing like a leather vest and like very gruff, like tasting his white dog.
Threw up all over himself.
No, he
Just laugh.
he made eye contact with me and almost doubled over. He started laughing so hard. I was like, well, glad I could help brighten your day, sir.
Oh my goodness.
Yes.
Yeah.
Okay. All right. Is it time?
Yeah, I just can't. There's nothing clicking over in here any longer.
Yeah,
I know.
I'm very sleeps myself. I'm ready for bed.
I've hit that point of like, I'll just stimulus response, but there's no self-awareness here going on anymore.
Hmm.
It's all over. Oh man, Bacardi 151. Yes. And Cisco. Oh my God, you guys, the terrible things. Many of them illegal in many places because there's such high alcohol content and are dangerous.
Yeah.
Yeah, 151 is
Alcohol in
still
the
around,
lab
but
is
not
used
everywhere.
to kill stuff. I mean, that's
Yeah.
Ethanol.
primarily what it's. Yeah.
Ta-da! I'm gonna go
Yep.
to bed.
Is it time?
Yeah, if there's anyone who's around right now who's in Portland area, I'm gonna be at Rose City Comic-Con on Sunday on a panel. Science does not work that way. Good night.
Huh?
Yeah.
Is that what the name of the panel is? Science does not work that way.
Good night.
Again, good night. Oh,
Science does not work that way. Good night. I get to be, I guess, amusingly upset about the use of science in movies and popular culture
yeah.
in front of people, which will be fun because I have a couple of favorites that I can pull from. It'll be good.
Yeah. What was it? I can't remember. I was watching something, one of these new sci-fi shows on Netflix, and there was something just sort of glaringly, like they flipped. They said two things because of this, then this, and they were both just completely wrong. Now I can't remember what it was. I'm gonna have to. It was no, it wasn't X-Men. What was the show? It's the one where the blobby things show up.
Oh my God. Yeah.
I think it's called Beyond. Yes, it's Beyond. There's something in Beyond that
check it out.
glaringly awful. But whatever. It was still a good show. I like the show. So I have to remind yourself not to complain.
Oh my gosh, if I complained about all the things that were wrong in everything on
You'd
television
be on a
and
panel talking
movies.
about it at a Comic-Con.
Oh yeah.
Yeah, so there's that. And then is there anything else going on that people need to know about? Calendar's coming.
Uh-huh. Yes.
We
I
all
will
have-
hope to have a cover image for you within the next week so we can start the pre-order process.
Cool. Awesome. Yeah, we should get that out soon. I can't believe it's September, you guys.
I can't even with it. But here we are.
Yeah, here we are. All the crazy things. Okay, yeah, no, now I'm just looking up random shows on Sci-Fi and the Science Channel going, what was wrong in that show?
That's such a horrible way to look at things, but
What was wrong in that show?
I get that it's an awful way to look at these shows in some ways, because you're here to enjoy a bit of fantasy, right? It's a little bit of the entertainment, escapism in it.
Yeah.
But if you have something that's trying to bridge the gap and tickle your hard science fancy into that fantasy land, and then they just do something terrible. It was a Comic-Con we went to, and somebody had an explosion go off from a cannon, and because there were 2 slits in the front of this building, it created the scatter pattern on the back wall, because that's how physics.
I thought you were gonna say it created both a particle and a wave.
No. It created the scatter that light does, right? Interacting with it. That unobserved double slit experiment because of an explosion. And I went, and the guy next to me goes, "That's not how that works." No, yeah. There's some author retelling a passage of like how he tries to incorporate science into his books because he has this explosion and it goes through these 2 windows and it creates this. But maybe it's at least that they try. I don't know.
Let's try. Good old college try.
Yeah, it's sort of being like, it's sort of like, okay, here's my problem with it. Superman can fly. Fine. That's not a problem. Superman can fly because gravity doesn't exist 20 feet off the ground. No, stop. Now you're teaching people wrong things. That's what I have the problem.
Well, it's Superman can fly, but Batman can fall much faster than other falling objects.
Oh
yeah, when that happens a lot. When 2 people are falling,
be limited by that speed, the terminal velocity related to gravity and the mass.
No,
I don't have to be limited.
A little of the aerodynamics.
You fell off the building 5 seconds ago. That's all right. I'll just tighten up. And I'll catch you, no problem.
There's a little bit of aerodynamics that can come into play on these things. Have you seen the skydivers when they can switch positions? You know.
There's a little bit of aerodynamics, but there's also this thing called terminal velocity.
But I have noticed when 2 people are falling and one is trying to grab the other, if they reach out towards somebody, you move in that direction quicker.
Yes,
and
that's true.
The other one that always gets me is somebody is falling.
Because you know what? You're not just reaching out, you're reaching out and down because you're falling.
Yes.
Yeah.
The other one I love is when somebody is falling but grabs a rope or a cable or something and they hold on at the last minute and that keeps them from hitting the ground instead of either their arm being ripped off or
their sockets.
Like the worst burn on their as they slide down. And all the even thinking about it.
Speaking of these funny things,
excuse me,
you'll never guess who retweeted our tweet today. I don't know if it did anything, but our retweet today from This Week in Science to remind people to tune into the show tonight.
Who? You
want to know who retweeted?
Who?
See if I can.
Hi, Adam.
Read the one over the top.
Yeah. That's great. Well
Ah,
done.
that's so fun, isn't it?
I got really excited yesterday because I woke up and I saw a notification on my
And then
phone
Gord too.
that said Leonardo DiCaprio followed you. And then I went and I clicked on it, and Leonardo DiCaprio, quote, had 30 followers. This
He's
isn't
very
the real
selective.
one.
No, it is. It's him. He's just very selective.
He does the unfollow. He does the little block follow. He's like,
Yeah.
He doesn't have one of those auto follow things.
I thought it was
No.
possible because he follows a lot of animal-based accounts. He's all about climate change and the Wildlife Conservation Network and stuff. And I was like,
no. It could have been.
Yeah.
Yeah, Gord, proximity to Adam right there. It's amazing. Well, my phone didn't melt, and we're still here. We hope that other people will be. You guys are all here.
I think Blair
Ladies,
left.
gentlemen,
Blair left. Where'd she
Blair
go?
left. She's like, I'm done. Never mind. I'm done.
Oh, she's back. Say goodnight, Blair.
good night, Blair. Say good night, Justin.
Good night, Justin.
Good
Good
night,
night,
Kiki.
Good night, everyone. Thank you once again for being here with us. We'll be back next week. David Quammen, Tangled Tree about evolution and life. We're going to have an amazing weekend, aren't we, everyone? So we look forward to seeing you next week. Take care. I got to figure out where my mouse is, and I'm going to click the button. Good night. Thank you.